All right. Hello, everybody, and welcome to this conference session, Making Crusty Code Testable. My name is Lauren Cunningham. I'm the Information Systems Team Lead at Synergex, and I'm joined by our presenter, Synergex Software Development Manager, Marty Lewis. Little bit about Marty. Since joining Synergex in 2007, he's worn a variety of hats kind of across the board. As both a software engineer and a manager for the Workbench and Synergy DBL integration for Visual Studio products. He was instrumental in the delivery of traditional Synergy support for SDI, and was more recently the architect for the new unit testing support for traditional Synergy. He now serves the company as a software development manager and works across teams to improve processes and to innovate. We're about to get into the pre-recorded portion of this. There'll be time afterwards for Q&A with an opportunity to use your mic if you so choose. In the meantime, if you have any questions, you can post those to either the Q&A or the chat areas. If you have any technical issues, please contact classes@synergex.com. And if that email isn't posted in chat, I'll be doing so shortly. And just as a reminder, this session is being recorded. So without further ado, let's go ahead and kick this off.
Welcome to Making Crusty Code Testable. It's great to have you all back. I'm Marty Lewis, one of the software development managers here at Synergex. There's nothing left to do but jump right in. If you're here for this presentation, I bet at least half of you are wondering what exactly we mean when we say crusty code. So one of the first things that we will do is tackle defining crusty code as a concept. In order to then make crusty code testable, we need to understand the bar for what makes code testable in general. So that's where we'll go next. Then we'll talk about some of the techniques that you can employ to improve your code, crusty or not. And finally, I will walk through an example of employing some of those techniques. Now, there's no silver bullet here. It's definitely work, but I think it's work worth doing. So let's jump right in. So who or what am I calling crusty? Just to be clear, this is not meant to be derogatory. This is simply meant to refer to any code base that has a buildup of technical debt. It's not specific to us or you, and I bet that every organization has some crusty crustables kicking around. Whether your technical debt is lack of maintenance, or design patterns that haven't scaled, or simply that no one goes back to refactor when your company updates your style guide, you probably have some crusty code out there. Today, we'll primarily be focusing on crusty patterns that we often see in Synergy code, with the goal of making your code more testable. So, if I were to print one of your subroutines, would it look like this? Maybe like 5,000 lines of data division, another 40,000 lines of code. So much so that you start running into compiler limits. Maybe you've even encountered the dreaded segbig error in the process. Big files is definitely one of the crusty patterns that we see most commonly. Chances are good that each of you has at least one, or more likely 100, of these massive routines that handle everything from input to complex business logic to file output and everything in between. Sure, you've done everything you possibly can to have some separation of concerns within the scope of this thing. You utilize internal subroutines to break up operations or partition off work that needs to be done more than once. And you have huge amounts of comments to ensure that someone coming in can understand the flow. You do have comments, right? In order to power a subroutine of this magnitude, you have to have a giant data division. Each of these sections of logic requires their own records, or each type of operation probably requires its own record. And then you have to ensure that all the structures and repository includes and everything else is present that you could possibly want. In order to facilitate this logic, you have to include pretty much everything. Suddenly your data division is bigger than some of your entire classes in other parts of your source code. In order to call this subroutine, you have to be able to provide the right set of arguments, right? With every piece added on, we probably added another input argument or 2 or 3, maybe an additional output argument. Big argument lists are a whole different type of crust because Now you really need to rely on IntelliSense to even know how to call this thing effectively. What about other Crusty patterns? Perhaps you've used what I like to call one include to rule them all, whereby every one of your source files or routines has to dot include a single master include that contains every structure, every common, every define. Now you have a 30,000 line maintenance nightmare that changes all the time. This throws your awesome new build setup in VS right out the window. All that dependency analysis figures out that a primary include has changed, so every one of your source files need to rebuild each time it updates. Or maybe your code exploits undeclared arguments without explicitly setting up var args. Now you don't even have that argument list in IntelliSense to guide you on how to call a routine. Imagine your subroutine as a black box. The argument list is a loose set of instructions, and then you start using undeclared arguments, and now it's a torn up, loose set of instructions. Undeclared arguments, overuse of past, anything that obscures the logical flow, it all adds up to a crusty layer. How long has it been since you had to bring a new person up to speed on your source code? Did they see go-tos and immediately have a look of confusion? Or perhaps were working in the code and just couldn't figure out how to trace and follow the code paths effectively? Software classes have been teaching that go-tos should be avoided for ages. Nothing says crusty to your new people quite like go-to. Some of the crusty patterns that we see have actual measurable impact on the performance of your application. Yes, lack of optimization is its own flavor of crust. It's easy to shrug these all off as, yeah, it's working well enough. But when performance improvements shave off a few milliseconds or longer, here and there, it adds up to a lot over the course of an application's lifetime. Especially when your software runs for 20, 30, 40 years. Highlighting just a few, you really ought to use the error equals label syntax instead of using on error label. The runtime is optimized to service that error list, and this is especially a better choice than using on error loop where you then sleep and retry operations in between. Let the runtime govern the flow. When doing your ISAM reads of massive records, please don't use %atrim to get the record length. If you have a 65K record, you're paying a big processing overhead. You've already read the record. Use %rdlen instead. And finally, while I love small compartmentalized operations, you should try to avoid calling a subroutine where the first thing that routine does is check a value and exit. You pay an overhead for those calls, and that cost is multiplied in .NET. When possible, just check before you call. One question I want to explore is, why do we have crusty code? It seems very prevalent, so how did we all collectively get to this place? Well, for one, we write some complex business logic with very specific rules for your industry. It's awesome. It fulfills the need and you're able to make sales as a result. Maybe you had to cut a few corners for that MVP, but largely it's meeting all of your code style and architecture requirements at the time. But that time might have been 10, 20, 30 years ago. Over time, your maintainers for that code move on, or there weren't very many to begin with, and anyone that peeks in sees there's not enough test coverage and nopes right out of there. No one wants to touch it. There's no tests to validate changes. Anyone who wants to make updates is just nervous to do so. Finally, someone needs to make a change. It just breaks everything. Maybe the business loses some money, maybe a customer goes down, but from there on out, all changes are forbidden. Now your code is effectively stuck in a vault. Untouchable, untestable, hard to change without really explicit authorization. So not only do you have some crusty patterns, but there's layers of dust hardening into a crust constantly. I think it's past time to de-vault your code. Dust it off, decrust it, spend some time making it testable, and make it feel like an asset again instead of a liability. So what makes code testable? What is the bar? How do you think about improving your past code? And what do you need to think about with present and future code? Fortunately, there are a number of core attributes that are commonly used to objectively judge whether or not code is testable. First one, cohesiveness, or the degree to which the elements inside of a module belong together. Do the methods and data of a class meet the unified purpose of the class, or are they just additions? How much is by design, and how much is bolted on? Loosely coupled is a big one for testability in new development. We work really hard to ensure that different modules of the software don't have tendrils of interconnectedness woven between them. You can't really test your widget in isolation if it depends on every other widget in the system. Well encapsulated is really just the natural progression of the previous two. Your software is well encapsulated if you restrict the direct access of data or components that should not be accessed externally. We usually do this by paying attention to accessibility in classes and only exposing what we want to expose from an interface. Code is also testable if it's in charge of its own state. Ideally, you can even write your classes to be mostly stateless, but if you are going to have state, it should be local enough to the context where it is used and not be modifiable externally. And finally, in order to be testable, code has to be accessible. I'm not referring to accessibility from the OOP perspective. If you cannot call it, you cannot test it. This is particularly relevant to code hidden away inside of internal subroutines in Synergy. We can draw comparisons between microservice architecture to code architecture. The microservice architecture is testable because you have a number of encapsulated units that do work. You can closely control the inputs and outputs, and then validate that you get the expected results. When we design code that more closely matches the architecture on the right instead of the mashup on the left, we have a much easier time writing tests that we can rely upon. It enables us to move much more quickly. So, from the list of what makes code testable, I really want to focus in on the last two today. If you want to tackle the rest, that makes sense, and that's up to you. But from a bang for your buck perspective, I think these are the items that would outright prevent testing if not met. What does in charge of its own state and accessible look like from a Synergy code perspective, especially one that utilizes a lot of internal subroutines? For an example, I'm turning to the internals of Toolkit. In this sample, we are knee-deep in a subroutine called WinScr, though you might not know it from the level of documentation that we have on the internal subroutine. This internal subroutine does a pretty good job of controlling its own state. Right at the entry, it sets default state for the variables that it needs to work with. But in doing so, it has wiped out the data for anyone who has called it. In order to test it, or the things around it, you would need to unravel the relationships of that data, so there's no real ownership of the state inside of this process wind routine. Simultaneously, you could not even directly test process wind even if you wanted to. Since it is internal to WinScr, it can only be called inside the scope of WinScr. So accessibility is a complete blocker. If only process wind were a separate subroutine, then we could call and test it directly. But since we're so tightly coupled to the records inside of this subroutine, that would require a lot of duplication and untangling. But what if it was a method instead? What if WinScr, the subroutine, were now a class, and all those internal subroutines became methods? We could still preserve the general shape of the records and state by moving it into class fields, and then those internal subroutines would be callable, testable, and methods. It might take a little bit of work, but the general shape should be compatible with pretty minimal risk. Well, I guess there's nothing left to do but actually refactor some code to see how bad it'll be. If we're going to refactor some Crusty code, the first thing that we'll need is some code. And what better than some toolkit code? It's my own source space. I can do with it as I please. And it definitely makes use of some of the patterns that we've talked about today. So before you do any sort of refactoring, make your life easier. Make sure it's one subroutine per file before you start. It kind of encapsulates your effort and avoids a much bigger mess with some of what I do to do this refactoring. And in the process, you might find out that many of your subroutines don't control their own defines. So they might be making use of the fact that defines extend beyond the scope of end, and when you move them to separate files, you're missing some stuff. So, separate files, good starting point. So we're going to take Winsker, and we are going to turn it into a class. Classes need to exist in a namespace, so let's go ahead and pick one that will work for us. Names key. There we go. This is part of script, so we'll go ahead and use the script namespace. So after that, we should make sure it's got a matching end namespace. So let's go to the very end of the file, end namespace, and we're going to go ahead and Control KD this file for formatting's purpose. I hope no one gets mad at me for that later. But for the purposes of our demo, it'd be nice to have everything aligned. Now, we've got a namespace. We don't really want a subroutine in the namespace, but before we go any further, we should make sure that we've got a copy of the header of our subroutine. This is going to be important because later on we're going to bring our subroutine back because we want everyone who calls this to be unaffected by the way that we make changes today. So I'm going to go ahead and grab that, and we'll go ahead and store that in a new file. Perfect. So what's next? Well, let's start turning it into a class. What we really want to do is take subroutine Winsker and turn it into class Winsker class. And fortunately, I have a little bit of regex to make that easier. So if we do a find, we enable the regex feature, and then take my replacement. We have just transformed .subroutine into class Winsker class and generated a constructor for that class. This is important because that constructor is going to be where the entry point of your method continues to exist. So after that, we need to transform all of the end subroutine or end or dot end or whatever it is that you've got to be the actual end of the method and into the class. So we can go down to the end of the file, take our dot end, turn that into an end method and end class. Easy enough. From there, in order for any of this to work, we need all of the internal subroutines to be calls to methods instead. So all the internal subroutine declarations need to be turned into method declarations, so those labels, and all of the call sites need to turn into method calls instead of label calls. So let's start with the callers. Go ahead and take another regex expression. I know when you introduce regex, you now have two problems, but when they're already constructed for you, it's less to worry about. And we're going to turn that into method calls. And so what this is doing is it's getting a match group for your white space, another match group for the call part, and another match group for the thing that you're calling. And it's preserving your white space and your call name. So all 5 of our internal routines have been replaced with calls to methods, but those methods don't exist yet. So let's get that done as well. So next step, we are turning all of the labels into method declarations. And we're going to go ahead and take an end method along with every one of these replacements. So we've replaced 7 instances. 7 is different than 5, so we might need to come back to that. And at every place that we have generated a method header, we have also put in an end method. And this is assuming that we want to terminate the previous context at about this spot, which if your labels are laid out in in a sane fashion, this is probably going to work for you. But we should go ahead and take a look at all the places where this has happened. But before we do that, one final thing to run replacement on, we need to make sure our return statements turn into M returns. If they're not M returns, they are definitely not going to work. So, what has happened with our method and methods? Let's go ahead and take a look at where they all turned out. We've got a method process command. That seems sane. We've got a method mField spec. This guy is inside of a case though. So this might not be an internal subroutine. This might just be a label for goto. And what we've done is we've now created a method where there can't be one. So it's really important that when you do this kind of replacement, you evaluate the things that got replaced. If I'm inside of a case, I can't insert a method there. You can't just put a method in the middle of a case or middle of a using or the middle of some other scope. It has to make sense. So we do have a little bit of cleanup to do. Let's go ahead and wipe out our method there. Put that label back, and let's look for the next one. Bad CMD. That also sounds like a goto. And we're still, well, we're right after the case. We could just take a look. Goto, bad, nope. This one is safe to, oops, CAD, bad CMD. This one is probably safe to leave as a method, so we're good there. Oh, not really. Look at this. We're in the middle of an else case when we're creating this. So let's go ahead and turn that back into a label. Just because we didn't have a goto for it doesn't mean that it was a good candidate for conversion. This guy looks good. We are outside of the case and it's creating its own begin case. That's fine. Do pause and quit. These should all be fine. If you're wondering why this code is grayed out, if you've not seen this, we do have support for evaluating your if-defs, so we can tell whether or not the code is active based on the current project's info, based on your current defines. So did we look at all the methods? There's that one. And process wind. This definitely looks like an internal routine. It's got a nice comment body. Great, 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 great. So next step for refactoring this code. We've now created all of our internal routine methods and we've done a little bit of cleanup on goto. In order for this class to really be the class that we need it to be, we need to get this data division into our class. We want all of this to not be locals to the subroutine anymore. We want it to be fields on the class so that all of our methods can access it. Let's go ahead and grab all of that. I'm going to leave the .includes for now because those don't really belong in a class scope. We're going to bring that up here. And you can see our indentation still doesn't agree with where we're at. That's okay. We can fix that later. So now we have all of our data division content in the right place, but we can't keep these .aligns. We're no longer working on the stack. We're now working on the heap because we're in a class. So let's take off our .align on each of these records. And you could have other considerations that you'll need to look into for this, but this is the evident one for me on this portion of the source base. And then what about those .includes? So these guys don't really belong on the class. They belong in the methods. So we're going to need to go ahead and do a little bit of duplication, I think, for this to work. Actually, we do need one for our constructor so it still has access to them. And let's go down to the data division of process wind and process command so that we still have these available. What were our other methods? I think they were WinDebug. Yeah, it's possible that it needs it. It's included there. And do pause. And I don't know where de-exit failure comes from, so I'm going to err on the side of caution and bring this in. If I was going through, I would probably clean these back up some more to make sure that I don't have unnecessary includes in all these scopes. But for a baseline of getting us to functional, I think this is what we have to do. And then one final thing from a data division of our constructor, we have our arguments. These guys are going to get passed into the constructor when we call and construct this class, but we still use these all over the internal subroutines. So we're going to have to bring this up to our class proper as well, and still leave it in the constructor context. So let's go ahead and make a new record for that so they're just not dangly. Yeah, we'll call this routine args. Good, right? Not good. Not good. We have to be more specific with our types here. We can't just be A and N. We have to give these specific sizes because now we're fields on the class. So I'm going to err on the side of caution there. Just go big. I'm sure that will bite me later when I come to figure out what that version format is. But for now, this gets me to something that's class compatible. Do just a little cleanup for sanity. So we're all done, right? We've got a class, we've converted all the methods into their appropriate separate pieces, and we've maintained all of these arguments. No, we still have to bring this guy into the class context. So when we're doing our constructor, these guys need to get set onto the class, and that's not going to be automatic for us. So let's go ahead and do this dot a done equals a done. This dot a libchan equals thankfully, IntelliSense helps me out quite a lot here, so I don't even have to remember what the names of all those were, and we have a naming convention that means I know they all start with a underscore, so I'll just do all of them like that. Now we're actually done building the class, but we're not done with refactoring this file. In order to stay true to our goal, which is to still have a subroutine that's callable exactly the same way from all of the other parts of the system that then refactors into this class, we still have to have that subroutine there. That's why we copied off this header. So if we grab this header back, come outside the namespace. You don't want to leave a subroutine in a namespace. That doesn't mean anything. We need a dot proc and a dot end. And then, just for sanity, let's have a record. We're going to, as the body of this subroutine, make an instance of our class. And that's it. When we call that constructor, we'll pass in all the arguments. If any of those arguments have out arguments, they should all flow through. And we should still work inside the context of the system. So let's call this our windscr instance. We'll declare that as windscr class. We'll be strongly typed today. And then windscr instance equals new. Not sinscr, windscr class. And we have to give it our argument list. A version, a ttchan, a lib, a scr, a done. Right? Right. So now we will create an instance of the class. We will pass all the arguments, and we'll figure out what all these red squigglers are about. But let's try building. Oh, there is something that we have to do. We copied around all those dot includes, but the original one had a dot in it, or had the comma in it. So let's go ahead and clean those up. We only need that on the first one in the constructor, because that's still the appropriate place to do the init. And these kinds of things you'll definitely run into while refactoring. And even though these other ones don't show up in the error list, let's go ahead and clean them up. So when I go to build in DBLnet, I don't give myself a headache. Build. Did it work? We just refactored part of the actual script utility in Toolkit to be a class instead of a subroutine. Now, it's not perfect. There's definitely some things to consider in here, like, do I have any hat pass that I need to work with? Oops, not 6pass, hat pass. I don't have any in this file, so I don't need to worry about it, but that's definitely something to consider. And go-tos. I only have the one in this file, and we did have to solve this guy's declaration. But if you have go-tos that go across what would have been method boundaries, that's not something that's going to work either. And there will be other hiccups in this process, but the tools are so good now, it's not too hard to work through them. Granted, this file is not 40,000 lines. You definitely are going to have to set aside more time to refactor an even bigger file. But what I found out in the process of doing this myself is that most of the refactors follow a pretty general flow. You get the same issues in every file, and you get faster at it the more you do it. And it's not too hard to just set aside some time incrementally to make these improvements in your source code, and then add some tests. So we touched a bit on these considerations during the demo, but it bears reiterating. There are some considerations when doing this kind of refactor. Like, how do you manage go-to across methods? You will need to evaluate those on a case-by-case basis and determine the best way to handle it. In many cases, they can be replaced by a method call. Fortunately, the compiler will help you identify these and give you an error when you're trying to go to something outside the scope. You also need to decide what to do with hat pass logic. You could make an array to generally store state about your args in the subroutine body and pass that along, or decide how important that information is to you in general. I ended up just writing a utility.include to handle this scenario, since you can't otherwise encapsulate hat pass logic. I did something similar for managing var args in a consistent way. And finally, just because it compiled doesn't mean you're done. If you're doing this effort, you might as well write a few tests to validate your new methods. Really quickly, I also want to touch on the one include to rule them all, since build performance is so important to me and all of you. By all means, keep your one include to rule them all if you really like it, but limit it to defines and macros if at all possible. Move your structures and repository structure includes to a namespace and just .import that instead. This lets us make use of strong prototyping when evaluating your code, and those structures should behave the exact same, and now you avoid accidental duplication. And more importantly, you will avoid unnecessary rebuilds. It's great and all that we have now done some restructuring to make code testable, but what about actually testing your code now that you put a bunch of effort in? Rather than talk at you for another 40 minutes myself, I encourage you to tune into Unit Testing Crusty Traditional Synergy Code. Arif is going to take the same source base I used and dig into writing some tests. And with that, who has the first question?
Could you expand more on what the issue is with the hat passed?
Yeah, I guess I didn't really do a very good job of explaining why it was a problem, only stating that it was a problem. So hat passed relies on access to the argument list of your current routine in order to evaluate whether or not that argument was passed. And since we've just refactored everything to be class methods, the context of where those arguments was passed is now a couple steps back. So it's back where the subroutine call happened rather than in the running scope of your method right now. So my proposal for how to work around this kind of problem is basically when you call that subroutine, store off some information about your arguments, so you could just build up a little array of whether or not they were passed and hand that off to the class so that you still have that info. But it definitely takes some thinking beyond just continuing to call hat passed and check whether or not the argument was present at all the places where your code might do it right now.
Okay. And Gary Hoffman, I see I see your message. I guess that one was wanted across the board. All right, I've got a question. So are there any performance implications to using classes and methods over subroutines?
That's a great question. So there's definitely a little performance difference between the way that subroutines and methods are called, but it's going to be negligible, especially at the scale that you're calling these routines anyway. I wouldn't think that you're likely to see any measurable performance difference in user code.
Okay. And on a similar vein, I noticed the code sample only has a few routines. How does this tend to scale with more substantial bodies of code?
It scales well. It's just the problem of ensuring that all of those labels get translated correctly. So some of the larger ones that I've converted were in the thousands of lines, and it's just taking that fine-tooth comb and double checking where the replacements happen. But otherwise, you run into the same patterns, the same problems on every source file you encounter. Especially if you're one company and one source base, you tend to have a lot of the same patterns over and over. Me looking at customer code, I've seen hundreds of different ways that people approach these things, but usually you'll have consistency in your own stuff.
Got a question from Gordon Ireland. Thoughts on passing lots of parameters to methods versus making them public properties?
Absolutely love refactoring to properties instead of making them arguments on the methods. For the sake of the example, I just wanted to have kind of the minimal changeover to get you to a functional class, but that's absolutely the route that I would go, is if it's intended to be generally available, and I kind of want better control over these things, and since they're already going to be members on the class anyway, I would make them properties.
Okay, got a question from Andrew Baker. Are there any memory differences with many small methods versus a single giant subroutine?
You shouldn't see any significant memory differences. We still only have one instance of the class, and all of the data that was associated with this logic. So all of the actual overhead is only paid once, just like if you were calling the subroutine. If for some reason there was concerns or constraints, you could approach this as a static class instead of an instanced class. Like if you really only need one version of these things to ever exist. But generally, I don't think you would see memory problems between the two.
Okay. I've got a question here. Would it be better to use a class with static methods?
Yeah, that's sort of what I just touched on too. It really depends on what your needs are, and if you kind of need things to behave more like global state than instanced members. For most cases, the closest comparison to what you get right now in a subroutine and its members is to do an instance class. You could do a static class if you want to change the dynamic a little bit. But I think generally an instance class is the way to go, because if you do further refactoring later, you haven't put yourself in a position where now you've got to worry about how this data is accessed from different users, and you're not running into things stomping over each other.
All right. The process of uncrusting code seems pretty mechanical. Are there any tools to assist in the process or review code and provide some analytics or lists of opportunities to update code?
That's a great question and a great suggestion rolled into one. We don't have any tools today to assist with the decrusting of code, but the more that I see common patterns, the more I'm thinking of tools to make this stuff more obvious, whether that's presented as an external tool or things that we can do in the compiler, like warnings to showcase to you where problem areas might be. They're definitely on our mind all the time. So if you have specifics that you'd like to see, I'd love to hear about them, especially Ideas Site is a great way. We review those every other week and have discussions about everything that goes on there. So if you've got ideas on what you'd like to see or how we could help you identify problem areas, I'd love to hear more about it.
All right. So thank you for joining us. We'll be back tomorrow for our next sessions. First is the one that Marty has already plugged and recommended, unit testing Crusty traditional synergy code. And we also have the using BI tools to create dashboards, KPIs, and analytics session. I hope to see all of you there. All right. Have a good day, everybody.